Hi, welcome. We are here for extending data centers to the cloud, connectivity options, and best practices. Now, we'll be spending the next 60 minutes together, so it's only appropriate that we get to know each other a little better. So starting at the back, can I request you to stand up and give an introduction about yourself? I'm just kidding. My name is Sid. I'm a solutions architect with AWS. I've been with AWS for 4.5 years now. And this is my third year repeating this session with the same title name. And it's been amazing to see how AWS has evolved over these years, and this session along with it. I was also fortunate enough to author the AWS Advanced Networking Certification Study Guide. So if you have any feedback or questions around this, please catch me after the session. Now, we are all network architects, network engineers, enthusiasts in this room, so we know that networking and connectivity is fundamental for our applications. But I do want to stress on the importance of choosing the right connectivity type. Networking is cool, right? But its sole purpose is to serve end-user applications. Hence, the decisions we make and the networks and the connectivity we build is so that our business-critical applications can communicate. So it's critical that we make the right decisions in choosing the connectivity options. So by the end of this session, I hope you have a clear understanding of what the various options are for connecting into AWS, and more importantly, what's correct for your workload. And we'll talk about different pillars through which we will evaluate each and every option to come to that conclusion. Finally, we'll talk about what's new and how it impacts your decisions when making these connectivity architectures. Now, today we are talking about hybrid IT connectivity, so let's do a level set on what hybrid environments mean. So the idea is that you have your own data center, and then you have AWS infrastructure, and you want to connect them. But why? Because you have workloads. You might want to archive your on-prem data into AWS. You might want to create a disaster recovery site in AWS or do an actual application migration. Or you're launching virtual desktops in the cloud, and they need access to internal on-prem systems. You might be running a split-tier application where some tiers are in the cloud while others are on-prem. In reality, it's a mix and match of all of these workloads, but one thing is clear. The connectivity better be done good to support these workloads. So there are broadly three ways of connecting into AWS. Number one, use public internet. The idea is very clear. You expose your systems to internet, and then you assign public IPs to the AWS infrastructure and have them communicate over public internet. Is it a good idea? If you ask this guy, he's going to say, yes, go ahead. But if you ask your security teams, they might not be OK with it. The bottom line is there are some workloads which can use public internet, but for most, we want to look at the other options. So the second option is VPN, where you create an encrypted site-to-site tunnel between your data center and AWS. It's still over the public internet, but now it's encrypted and authenticated. There are three ways to terminate VPN on AWS, and we'll go in one by one into more details. And we'll also talk about the Transit Gateway, which was released yesterday. The third option is AWS DirectConnect, where you create dedicated circuit between your data center and AWS. This gives you consistent network performance, and you get speeds up to 1 gig or 10 gig, and you can even go sub 1 gig. Now, you connect to us through third-party colo facilities. We call them AWS DirectConnect locations. We have 89 locations and growing across the globe. This gives you a snapshot of a few of the locations. And the idea is that through any of those locations, you can get connectivity into the AWS global infrastructure. And this is enabled by the AWS global backbone. So here you have connectivity into Perth, and from there you're getting access to all AWS regions except China. OK, so we now know broadly what our options are. Let's dive deeper into each of these options and evaluate them. But how do we evaluate them? We'll use these pillars. Flexibility. Think about feature and functionality. Think about how the connectivity option can adapt to your ever-changing workloads. We all have fixed IT budgets, so cost is important, and we'll talk about that. When you architect your workloads in AWS, we always say, go multi-AZ. What that means is that you're deploying your virtual machines and your infrastructure in multiple data centers, which are miles apart. And we want to have similar resiliency while connecting to that infrastructure. So we'll talk about resiliency. Finally, performance. You know your workloads best, so keep in mind what kind of performance you're looking for, and we'll talk about that as well. Let's start by talking about VPN connectivity architectures. So on the right, we have customer data center. On the left, we have AWS infrastructure, which consists of multiple VPCs. And what we are concerned about today is what's in middle. So let's bring in internet, because VPN is over internet. Now, there are 3 ways to terminate VPN on AWS. The first one is AWS Managed VPN on the Virtual Private Gateway. Virtual Private Gateway is a fully managed endpoint or a gateway. When I say fully managed, I mean we take care of the underlying infrastructure, patching, cabling, VPN configuration, high availability, failover, and all of that. You also see something called CGW, that's Customer Gateway. That's a logical representation of the VPN termination endpoint at your data center. Now, this Virtual Private Gateway is quite feature-rich. It supports latest cryptographic algorithms. It has support for NAT traversal. The IPsec tunnels are fully customizable, so you can choose your own custom pre-shared key. Inner IP addresses of the tunnel are configurable. You can go static routing or BGP. And if you're using BGP, you can bring your own ASN and apply it on the Virtual Private Gateway. And we also have support for CloudWatch metrics, which you can use to monitor the VPN tunnel. Now, creating the VPN is very easy. Using an API call or through the AWS Management Console, you can create the VPN connection. When you do that, the AWS end gets auto-configured with the IPsec and the BGP configuration. You can download a configuration file and apply it on your router. And this brings up the VPN connection. Once the VPN connection is up, what can you really access? Well, a lot of things. And the reason I have this slide up here is because everything which you see new was not available last year. So now we have added support for private link and all the services backed by the hyperplane, which we discussed last year. So network load balancer, elastic file system, and the newly released Amazon Route 53 resolver, which lets you query Route 53 private hosted zone of your VPC. So let's focus on what's not accessible. So the .2 of the VPC, that's the DNS IP. You cannot access it. So if you want to access DNS, use the Route 53 resolver service. Gateway VPC endpoint, which allows access to Amazon S3 from within your VPC, is not accessible. And just to be clear, this is only for the VPC. So you cannot access the AWS public IP range over VPN. Now, when you look at the configuration file you download, you'll see we give out 2 IP addresses. And this is how we manage high availability. These 2 endpoints are highly available and multi-AZ. It's recommended that you create tunnels to both these endpoints. And this is a default behavior. Now, you need to think about resiliency at your end. So we hope you'll have 2 VPN termination endpoints, and hopefully in 2 different data centers, if possible. So you'll create a VPN connection from the second CGW to the VGW. So now you have 4 VPN tunnels when considering high availability at both your end and AWS. Now, when you have 2 paths to reach the same network, one will be active, one will be standby. And you can influence that using BGP parameters like AS path prepinned. Now, we have been talking in the context of 1 VPC and 1 virtual private gateway. So if you had another VPC, you repeat the same steps and create 4 more tunnels to the second VPC. Now, think about that at scale. Creating 4 VPN tunnels for every VPC you want to connect to. You have 10 VPCs, 100 VPCs, you'll end up creating hundreds of tunnels. That's not good. We heard from you, we heard your feedback, and you were not happy with this kind of an architecture. So let's call this architecture that needs fixing. And we'll come back to it. Let's recap the AWS Managed VPN on the Virtual Private Gateway. It's quite feature-rich, but it lacks in flexibility in the sense you need to repeat and create more tunnels for every VPC. Resiliency is good at multi-AZ, and you need to think about resiliency at your end. You pay for what you use. You launch more tunnels, you pay more. And from a performance standpoint, you get up to 1.25 gigs per VPN tunnel, and you can scale them horizontally and get more bandwidth. But we don't do ECMP. We don't support ECMP on this. So for a given prefix, you can use only one tunnel. OK, let's talk about our second option, terminating VPN on an EC2 instance. So the idea is very simple. You launch an EC2 instance. You load it up with the software of your choice. You can use the AWS Marketplace to one-click deploy software, or you can use any open source software. You configure the VPN and the IPsec and all the BGP configuration on your own. You do the same on-prem, and then the VPN tunnel comes up. You probably want a pair of EC2 instances for high availability and build some kind of an automation around it so that if the primary fails, the standby can take over. Now, most vendors like Cisco, Aviatrix, Juniper, Palo Alto, everyone has some kind of an automation in place to help you do this. Now, let's bring back our architecture that needed fixing and see how we can use VPN termination on EC2 to fix this. Let's get rid of all those hundreds of tunnels. Let's bring in the transit VPC. Now, transit VPC is no special VPC. It's a regular VPC, but the functionality it's providing, that's the reason why we call it transit VPC. But the idea is that you have a pair of EC2 instances, which you launch in there, load it with a VPN software of your choice, and terminate tunnels to those EC2 instances. Now, from those EC2 instances to the spoke VPCs, there is also VPN. But then we are using AWS managed VPN on the spoke VPC. So this is kind of a hybrid of option 1 and option 2. Now, we released this architecture back in July 2016, and we saw tremendous adoption. We initially released with CloudFormation templates and automation using Cisco CSRs, and we saw a bunch of vendors follow through with similar architectures, Aviatrix, Juniper, Palo Alto, different vendors. And there was a tremendous customer adoption as well. And there were 2 reasons for that. One was that you don't have to configure your on-prem VPN device for every VPC you launch. And number 2 is that you get visibility into your traffic. You're not always connecting your on-prem data center to your VPCs. You might connect remote networks, untrusted networks, and customers needed the control over traffic and do some kind of an IPS IDS. And this architecture lets you do that because you can implement firewall controls and IPS, layer 7 filtering, whatnot, on those EC2 instances. So this was, it's a very good architecture, or is it? So there are some faults. These EC2 instances have limited bandwidth. IPsec is not a very efficient process, especially when done in virtualization. So you can get a max of few gigs per second. And when you have hundreds of VPCs behind those EC2 instances, that can be a limiting factor. You have customer management overhead because you are maintaining and managing these EC2 instances. You take care of HA, scale, and whatnot. And finally, you have to pay high licensing fees if you're using vendor software. So let's call this architecture that needs fixing part 2. Let's recap. Software VPN on EC2. You can use any vendor of your choice. It gives you quite a bit of flexibility from an architecture standpoint. But you have to pay in the resiliency point, because now you have to maintain and manage it. You have to pay vendor licensing fees, and also for those EC2 instances you're running. So not a great story there. Performance varies by EC2 instance size and type and how many of those instances you're running. OK, so the architecture that needed fixing, part 2. So let's fix this. And we do that by getting rid of the transit VPC and bringing in the transit gateway. Now, transit gateway is a fully managed endpoint. You can connect your VPCs directly to the transit gateway, so there is no longer VPN involved to connect your VPCs to the hub. This transit gateway has AWS managed VPN endpoint on it. Using that, you can create VPN to the transit gateway. So this gives you the VPN edge consolidation you were looking for. So just a pair of VPN tunnels, and now you can connect up to 5,000 VPCs behind it. There was a second feature we talked about when we were talking about transit VPC, which our customers love, and that was security, visibility into traffic. And the transit gateway delivers there as well. You have the ability to create advanced routing rules through which you can send traffic to an EC2 instance before it makes it to the final spoke VPC. And on that EC2 instance, you can run IPS, IDS, or some kind of a firewall. So let's dive a little deeper into transit gateway. Now, this is not the session which will give you everything you need to know about the transit gateway. Transit gateway is a much broader networking construct. But we'll be talking about this from the eyes of hybrid IT connectivity. So transit gateway lets you build hub and spoke network designs, where the transit gateway sits as a hub, and you have a bunch of spoke networks. You attach your VPCs to the transit gateway through a simple API call. It's native attachment. And these VPCs can belong to multiple accounts. So we do have multi-account support on the transit gateway. You connect your remote networks via VPN over BGP using the AWS managed VPN endpoint. And you can also connect via DirectConnect, but that's not here yet. This is expected early 2019, so please keep that in mind. It's not here yet. So for this discussion, I'm going to get rid of DirectConnect, but the feature and functionality I mentioned now is also valid to DirectConnect once it makes it. The transit gateway has its brain. That's its routing table. That's how it makes all the routing and packet forwarding decisions. At the VPC level, you'll just write a static route pointing your default gateway to the transit gateway. Now, let's say VPC-C wants to communicate with the remote customer office. It sends a packet to transit gateway. The transit gateway looks at its routing table, sees, yeah, I have a route for the remote network, and sends it off. Fairly simple. And this is how the hub and spoke model works. It's like a brain sitting in the center of your architecture. Now, let's talk about the security aspect of it. And for that, I want to introduce to you the concept of multiple route tables. The idea here is that the transit gateway doesn't need to have just one route table. It can have multiple route tables. And you can associate different spoke networks to different route tables. So the routing decision or the packet forwarding decision which transit gateway makes will vary based on which spoke network the traffic is coming from and which route table it is associated with. So let's try to understand this with an example. So I create purple zone and red zone, and the networks in the purple zone are connected to the purple route table, and the networks in the red zone are connected to the red route table. Now, the route tables are fully customizable. So you can start with an empty route table, add static routes. You can propagate routes from the VPC or from the BGP session. So it's fully customizable. So what we do here is we put the routes of the remote networks in that zone, in that route table. And the same for red. So now let's see what happens if VPC-C wants to talk to the remote office. It sends traffic to the transit gateway. Transit gateway looks at the red route table, and it sees it doesn't have a route for VPN1. It drops the traffic. So what you essentially did here is you created logical isolation of the red zone with the purple zone. So if you have your test dev environments and you have production environments and you want to create isolation, you can do that. Now, as I mentioned, the route tables are fully customizable, which means you can now add static routes to forward traffic to an EC2 instance. So this is how it works. You add a static route in your purple route table. You say, my default, if the traffic is not within my zone, I want it to go to a security VPC. And that's where my EC2 instance sits. And the same for the red zone. So what happens now is when the remote office wants to talk to the VPC-C, it sends traffic to the transit gateway. Transit gateway looks at its routing table, sees that it's not in my zone, so let me use the default out to the VPC XXXXX. It sends it out there. It goes to the EC2 instance. EC2 instance does something with the traffic, sends it back, and then it goes to VPCC. All right, let's recap. AWS Managed VPN on Transit Gateway, you have the same feature functionality as AWS Managed VPN, but now you have added flexibility of edge consolidation. You can have advanced routing capabilities, send traffic to an EC2 instance in line, create different routing domains, isolation. Resiliency is inbuilt. And from a pricing standpoint, there is some additional charge for the transit gateway usage. Now, performance is key, because now you get 1.25 gigs per VPN tunnel, but now we allow ECMP, which means you can load balance traffic across multiple VPN tunnels and scale the VPN bandwidth horizontally. And we have tested up to 50 gigs per second of packet forwarding capabilities on the transit gateway. So it's very high performant. So the question arises, is transit gateway a new default? For VPN, yes. But as I mentioned, transit gateway is a broader networking construct. And to learn more about it, I would suggest one of these sessions, which is done by my peer, Nick Matthews. And you can learn more about the transit VPC and the transit gateway and sort of all the functionality. All right, so we just talked about VPN. Now let's jump to DirectConnect. So the idea here is that you create a dedicated circuit between your data center and AWS, and you do it via a DirectConnect location. It's a third-party colo facility where we have our cages and our devices, and we have redundant connectivity back from the DirectConnect location to the AWS global infrastructure. Now, step one is for you to decide which DirectConnect location you want to connect via. You might ask, how do I make that decision? Well, we'll come back to that. But for now, let's just say you made a decision. Now, there are three scenarios you can be in. Scenario number one, you have presence in the same DirectConnect location. If that's the case, it couldn't be simpler. All you do is, through AWS Management Console or an API call, request a DirectConnect connection, specify the port fees, the port speed, 1 gig, 10 gig. And within 72 hours, you can download a letter of authorization, hand it over to your colo provider, and ask them to do a cross-connect, and done. Second scenario is where you don't have presence. In this scenario, you'll still go and request the letter of authorization, but hand it over to a service provider who will extend a circuit from the DirectConnect location all the way to your data center. Now, you can work with your own service provider, or you can work with one of the 100+ AWS partners, which are listed on this link. Now, option 3 is interesting and slightly different. In this option, you don't go to AWS console and request a connection. You actually directly go to your service provider and tell them to connect you to AWS. Why would you do that? One of the scenarios is where your service provider maintains and manages a private MPLS VPN, which connects all your remote sites, and you want AWS infrastructure to be part of that MPLS VPN. Or the service provider might say, connect to me, and I'll give you multi-cloud connectivity. Whatever be the case, what's happening technically in the background is your service provider has existing circuits to AWS, and they're just onboarding you onto those circuits. So you don't get a dedicated 1 gig or 10 gig circuit, but you are leveraging your service provider's circuits. So what speed do you get? What's the resiliency model? How much do you pay? It all depends on your contract with the service provider and their offering. AT&T NetBond, Verizon SCI, Equinix Cloud Exchange. If you're familiar with these options, that's all in this category. Now, when you're choosing what to do, which option to go with, there are some considerations. One is how easy it is to add and remove virtual interfaces. We will talk about virtual interfaces in a bit, but just keep in mind that it lets you connect to resources inside your VPC. Hence, it's important to know what's the speed of creating those. And it will vary based on which option you go with. You might or might not want to have routing ownership and create those BGP sessions and exchange routes. So that will also vary based on which option you go with. Time to get connectivity to your resources is important. And that will vary based on the option as well. And option 2 probably is going to take the most amount of time because you have to create brand new circuits. And that takes months to do. Finally, cost is important. Now, there are 2 factors in cost. One is AWS charges, and other are circuit costs. Now, let's talk about AWS charges. Now, there are 2 parameters. One is the hourly charge for the port. So 1 gig, 10 gig, or sub 1 gig, whatever you get, you're paying an hourly charge for that port. And you're also paying for data transfer charges. Now, data transfer in is free. And this is global. So if you have connectivity from your data center to a remote region, let's say from US to Singapore, you can transfer a bunch of data to Singapore, and it's all free. But data transfer out will vary based on which region and which DirectConnect location you're using. In option 3, again, you're paying your service provider fees based on your contract, but you'll still pay for the AWS data transfer charges. So you might ask, how do I choose the right location? End-to-end cost we just spoke about is critical. How much does it take for you to build a circuit to that location? Latency is important. Think about latency. Depending upon which DirectConnect location you're choosing, what are my latency estimates? And finally, geographic redundancy. So you want to choose multiple DirectConnect locations which are geographically redundant and apart in case of failure. And this brings up to my next topic, which is resiliency. Now, let's say you decided to go with a DirectConnect location. So now you have your router, a single router, connected to a single AWS DirectConnect device over a single port using a single cross-connect. I mentioned single 4 times. It's all single points of failure. So we want to get rid of single points of failure. So let's add VPN. While VPN is a valid option, it does not give you the same performance as you would expect from DirectConnect. So you want a standby option which is more meeting your needs. So let's add redundancy with the ports and the cross-connects. So one thing you can do is use link aggregation groups. So let's say you had 40 gigs of bandwidth between your data center and the DirectConnect location. Then you can request 4 10-gig ports, bundle them together in a lag, and get 40 gigs bandwidth to AWS. Now, if any of those links or the port fails, the other links and ports will take over. But you still have single router and a single AWS device. So let's add redundancy there. Now, 2 weeks back, we released a feature which gave you logical BGP level redundancy. Now, what we do there is over a single DirectConnect connection, we give you 2 physical devices in the backend as BGP peers. So in case of failure or maintenance, it automatically fails over to the second BGP peer. Now, this is only available for one DirectConnect location now, so keep that in mind. But even in this scenario, you're still doing one cross-connect to AWS because it's one connection. So we want to add more redundancy. So for that, you get 2 DirectConnect connections. So it's 2 different cross-connects. And by default, we'll make sure that it's landing on 2 different AWS devices. You need to think about resiliency at your end. So hopefully, you're using 2 different devices for these 2 circuits. And if the service provider is extending circuits all the way to your data centers, then you're doing it on 2 different data centers. Now, when you have 2 paths to reach the same AWS resource, you can run active-active using ECMP, or you can run active standby. And we'll talk about how you do that in a bit. But this is still a single point of failure because it's still a single physical data center or a DirectConnect location or even a campus. So what you want to do is connect via 2 different Direct Connect locations. And hopefully, you are connecting via 2 different data centers at your end as well. Now, there's a confusion on what a Direct Connect location actually means. So this is a screenshot from our website, which lists all the Direct Connect locations. As you can see, the first column is the Direct Connect location, and the second is the campus from which it is accessible. Now, if you're getting 2 Direct Connects into NY1 and NY2 in New York, you are not getting redundancy, because the Direct Connect location NY1 is still a single point of failure. So you want to get connection to 2 different Direct Connect locations, which is basically 2 different line items in this table. And we love VPN, so let's keep VPN as our backup. So let's recap. You get global connectivity. You connect through 89 and growing Direct Connect locations. From a resiliency standpoint, it's recommended to have 2 connections in 2 different Direct Connect locations with VPN. You pay for port R fees, data transfer out charges. From a performance standpoint, you can get 1 gig, 10 gig, sub 1 gig, and you can get multiple of those links and do ECMP and scale horizontally in the bandwidth. Now, some of the features which we released over the last 1 year. We have support for bring your own autonomous system number, which you can apply on the DirectConnect Gateway. We added more CloudWatch metrics, which gives you better visibility into your DirectConnect links. IPv6 support, and now DirectConnect is a HIPAA-eligible service. And we also have support for jumbo frames. So now we have talked about the physical aspect of DirectConnect. Let's talk about how you get access to the resources like VPC and S3 and all of that over this physical connectivity. So let's say you connected via the SuperNAP 8 facility here in Las Vegas. The cross connects are done. The setup is done. And now you have your App 1 VPC in US West Oregon, which you want to connect to. Step 1, you create a DirectConnect Gateway. Step 2, you create a private virtual interface to this DirectConnect Gateway. You can create the private virtual interface via AWS console or an API call. But while doing so, you have to specify a few parameters. And one of them is a VLAN ID. The idea here is that your router will tag all the packets which it is sending to this DirectConnect Gateway using this VLAN ID. You also specify BGP parameters like BGP authentication password, BGP peer IP addresses, and the ASN numbers. But once you do so and you create this private virtual interface, the AWS end gets auto-configured. And you can download a configuration file and use that to configure your routers. Once you do that, the BGP session is up, and the DirectConnect Gateway is now a BGP peer to your router. Next step, using an API call or the management console, you associate the VPC and the virtual private gateway attached to it to the DirectConnect Gateway. And that's it. Now you have connectivity from your on-prem to App 1 VPC. Now, if you had more VPCs, like an App 2 VPC, you just associate that VPC to the DirectConnect Gateway, and now you have access to 2 VPCs. What about a remote region? The same step, 1 API call, and you associate that remote VPC to the DirectConnect Gateway, and you get access to all the 3 VPCs over that 1 BGP peering and 1 virtual interface. Now, when you connect your VPC to the DirectConnect Gateway, it becomes an extension of your data center, and you can access resources inside it using its private IP addresses. But which resources? This is the exact same slide from the AWS Managed VPN. So the list of resources is exactly the same. So I won't spend much time on this since we have already discussed what you can and what you cannot access. And this list is valid whether you're accessing a VPC in the local region or a remote region. Now, Transit Gateway. It is not here yet, But I just wanted to talk about how will that work once the support comes, early 2019. The idea would be similar, but now, instead, your DirectConnect Gateway directly connecting to the BGW of the VPC, it will connect to the Transit Gateway, which behind the scenes will connect to thousands of VPCs. Now, the Transit Gateway is a regional resource. So you'll have a Transit Gateway in your remote region as well, and you can connect that Transit Gateway to your DirectConnect Gateway. Now, we have been talking about how you connect to your resources via one DirectConnect location. And we just discussed that resiliency is key. It's important. So let's see how that works when you have multiple DirectConnect locations. So through the magic of PowerPoint, let's make that smaller. And let's bring in a second DirectConnect location. Now, if you wanted to connect to your AWS resources via the second location, all you need to do is create a private virtual interface over the second connection to the same DirectConnect Gateway. And that's it. Now the DirectConnect Gateway has two BGP peers, and that's your two routers in the two different locations. You can influence which path is active, which is primary, active and standby, by using BGP parameters, like AS path prepend. So in this example, where you do the path prepend becomes the backup, and the northbound link becomes the primary. There's another way to influence traffic. And you can do that by tagging your routes with specific BGP communities. So the idea here is that you can tag your routes with a community which is low and other which is high, and the high will be preferred. These is the list of the actual communities which you'll have to use to tag. And the idea here is that if you tag your routes with high, that will be preferred. And this is all to influence how AWS is sending traffic back. So how you send traffic to AWS is under your control, and you can use BGP weights, or you can use local preferences. Now, multiple accounts. I think this has been a major pain point. So let's talk about how multiple accounts work with DirectConnect Gateway. So let's say the application VPCs are in their own accounts, so app1 VPC, app2 VPC. And the DirectConnect Gateway was in app1 VPC. Now, we don't support the DirectConnect Gateway connect to a VPC, which is in a different account. So this won't work. The way you would want to connect is create a different DirectConnect Gateway in the app2 VPC, over the same DirectConnect physical connection, create a virtual interface to this second DirectConnect Gateway, and then connect this DirectConnect Gateway to the VPCs in that account. And this is how you can use a physical connection across multiple accounts. Now, I know it's still a pain point. We have heard your feedback, and you want the ability to connect DirectConnect Gateway in one account to VPCs in multiple accounts. And since this is a public forum and we don't have NDAs in place, I cannot give you roadmap information. But all I can say is we value your feedback quite a bit. Now, VPC endpoints. This is another important one. So VPC endpoints allows resources inside the VPC, like EC2 instances, access AWS public services without a need of an internet gateway. And you might think, OK, why are we talking about this? Because we have seen more and more customers want to connect to AWS public services leveraging VPC endpoints. So let's talk about how this works with VPC endpoints. So we have two kinds of VPC endpoints. One is the interface VPC endpoint. This is powered by Private Link, and it lets you connect to AWS services like Amazon Kinesis, load balancing APIs. And this interface VPC endpoint shows up in your VPC as a network interface. And this is accessible over DirectConnect. So we have support for this. So if you wanted to access EC2 APIs, You would create an interface VPC endpoint in your VPC, and that has an IP address from within your VPC, and that IP address can be reached over DirectConnect. The second kind of gateway is the gateway VPC endpoint, and this allows resources in your VPC connect to services like S3 and DynamoDB. Now, this gateway endpoint is slightly different. It's not an ENI. It's an actual gateway which attaches to your VPC, and it's a routing entity. Now, this gateway, unfortunately, is not accessible over DirectConnect. So you cannot connect to S3 and DynamoDB leveraging the gateway VPC endpoint. So how do we access S3 DynamoDB? Well, one option is to create a pair of EC2 instances, which will act as a proxy. So the idea here is that you'll proxy all the traffic to S3 via this pair of EC2 instances. While this is a valid option, there are some problems. One is that now you have to manage and maintain the entire fleet of EC2 instances which are working as proxy. Scale them, HA. And secondly, you need to configure your on-prem systems to use a proxy because they don't work in a transparent mode. So that brings up the public virtual interface. Public virtual interface allows you to connect to AWS public services over DirectConnect. And it lets you do that not only in the region where you have connectivity, but globally across all AWS regions. Now, public virtual interface is very similar to the private virtual interface in the sense that there's a VLAN ID associated, so you have to tag the packets. And there's a BGP session which gets established. But the key difference is that over the BGP session, we advertise to you the entire AWS public IP range. And that's a global IP range which consists of more than 2,000 prefixes. So let's think about that a minute. It's not just resources which belong to you, your S3 buckets, your DynamoDB tables, your public EC2 instances, but it's all of Amazon. So any customer running on AWS and has a public IP will be reachable. So we recommend that you put a firewall in front of the public virtual interface and do some kind of a filtering. Ideally, if you can do layer 7 filtering using URLs, that's the best. There are some other options. If you go to this link, this is where we list out all the IP ranges, and we list them out based on region as well as service. Now, the services which we list here is pretty limited. So it's S3, EC2, we have code build, CloudFront, Route 53, global load balancer, CloudFront. And I might have missed one or two, but those are the services which we list out explicitly. So you can use that information, and you can use the regional information to create some kind of a filtering. There is one more way. So when we advertise the routes to you, we tag them with BGP communities, which represent the scope of the geographic scope of the prefixes. So you can know which prefixes belong to the region in which you're connected, in which you have the DirectConnect location, which regional prefixes belong to the continent in which you have connection, and which are global. So that distinction is also possible using BGP communities. So these are some of the ways you can filter the routes. Now, when we talked about AWS Managed VPN, whether it was on the virtual private gateway or the transit gateway, it gives out two IP addresses, public IP addresses for VPN termination. These public IP addresses are also accessible over public virtual interface. So we can use that to our advantage. And what we can do is we can create IPsec tunnel over DirectConnect to the transit gateway. So this not only gives us access to the transit gateway, but it creates an encrypted tunnel to it. So a lot of our customers who require encryption over DirectConnect tend to go with this kind of a design. So when talking about DirectConnect Gateway, there are a few things to remember. Let's bring up a sample architecture where we have 2 DirectConnect gateways and a bunch of VPCs in different regions. Now, if you wanted 2 VPCs to communicate with each other via the DirectConnect gateway, that's not supported. So DirectConnect Gateway only allows for hybrid traffic, so from your on-prem data center to AWS and vice versa. If you want 2 VPCs to communicate, use the transit gateway or native VPC peering. If you have 2 VPCs with overlapping IP addresses, you cannot connect them to the same DirectConnect gateway. Although, if you had 2 VPCs with overlapping IPs, you can connect them to the transit gateway. So transit gateway supports connectivity to 2 VPCs with overlapping IP addresses. And you'll learn more of that in the other transit gateway sessions. I don't want to go into deep on transit gateway and some of the functionality around that in this session. Now, if you have a VPC which is connected to a DirectConnect gateway, it cannot connect to another DirectConnect gateway. So it's like a one-to-one mapping. Now, the DirectConnect gateway was released in November last year. So if you had DirectConnect prior to that, the way you get connectivity was to have a private virtual interface go directly to the virtual private gateway of the VPC. And that's the yellow line at the bottom. So if you architect it in that way, then you can associate your virtual private gateway to the DirectConnect gateway and get rid of the old connectivity type. And that's one of the ways you can migrate to the DirectConnect gateway model. So when we started out, there were 3 key takeaways which we discussed. So now I'm going to judge and quiz you to see if you were paying attention. And I have a few prizes here, so you're in for a treat. So what are the options for connecting into AWS? The option F looks very interesting. I should try to do a POC around that. So if you can raise your hands if you know the answer. OK, I saw that guy right there first. So yeah, you. There are 3 options here. Yeah. E as well? That's correct. So you get a prize. So you get this fancy colored pencils, and you can use these pencils to draw connectivity architectures. You can come in. Congratulations. So we saw that you have VPN and AWS DirectConnect you can connect via. And then you have Transit Gateway, which brings new possibilities and new architectures. With DirectConnect, you have private virtual interface, which gives you access into a VPC, and public virtual interface, which gives you access into public AWS services like S3. And you need to take care about how you're working with the public virtual interface. The second key takeaway, what's appropriate for my workloads? So let's look at a question. You have a business-critical hybrid application, and it requires low latency, 10 gigs bandwidth, and minimal downtime. So you need a resilient, highly available architecture. So do you use VPN with tunnels to both the endpoints? You use DirectConnect with connections to different DirectConnect locations. You use internet, or the application has too many expectations, and we need to re-architect the application. OK, right there. Sorry? B, that's correct. So you get a prize. So you get a magic ball. And if ever you fall into a scenario where you're not able to decide which AWS connectivity option to go with, you can use the magic ball. All right, congratulations. So we saw different pillars through which you need to judge your connectivity type. And you'll have this slide. So you'll have all that, the matrix which we saw. Flexibility. We saw Transit Gateway added a lot of flexibility. Cost is important. Think about circuit costs, vendor licensing costs, And finally, resiliency is key, and performance. So when you're evaluating what do you require for your workload, look at these different pillars. Look at some of the stuff we talked today, and you can make a decision of which option to go with. Now, the final key takeaway, what's new and how does it affect my architecture? All right, so which of the following new releases allows you to consolidate VPN connectivity for up to 1,000 VPCs and lets you define advanced routing rules? Virtual Private Gateway Reborn, DirectConnect Super Gateway, or the Transit Gateway? All right, let me go there at the back. Yeah, sorry, at the back, yes. Yep, yeah, that's you, yeah. Transit Gateway, that's correct. So you get a prize. So you have a LOL surprise puzzle. So in case the new AWS releases doesn't surprise you enough, you can always use this puzzle and get amazed. Thank you. All right, congratulations. So we saw what's new. We saw we have Transit Gateway, which got released. And it honestly changes quite a bit of things. You don't have to use EC2 instances in your Transit VPC anymore. You can go with Transit Gateway, which is providing you with similar functionality, but now it takes care of resiliency, scalability, and it's fully managed. AWS DirectConnect provides you logical redundancy over a single virtual interface that's just limited to one location right now, but it opens new ways of achieving resiliency. All right, thank you, and please don't forget to complete your session survey. I'll take any questions you have. Thank you.